Hello everyone. Let's take a look at homework 23, compound probabilities. Here we pay close attention to whether or not these events are dependent or independent. If they're dependent, then one event changes the next, so you change the denominator as you go. So we'll go through these problems. If you want a copy of this file to work it out on your own, let me know. I have it saved. But this is just a version of what you will see in homework 23. A lot of you have already completed it, so I'll try to get this uploaded quickly. Number 1. A deck of cards is randomly dealt by a computer during a game of Spider Solitaire. Find the probability as a reduced fraction that the first card dealt is, and then we have 3 options here. So, all of this really doesn't matter. We're just finding the probability of drawing a card. So first we have a 7 or a heart. If it's an or question, so we kind of start off with a more difficult one. If it's an or question, this is where we add, but we also have to subtract the overlap. And that's because it is an or problem. So, in a deck of cards, you'll have that sheet available to you, something like this. Half the deck is red, half the deck is black. You have hearts, diamonds, spades, and clubs. So here it's asking about 7s or a heart. We have 4 7s, and we have 13 hearts. So, out of, if we're talking about a deck of cards, it's out of 52. And so for my 7s, there are 4 of them. And to that, I add my hearts. In a deck of cards, there are 13 of each suit. So there are 13 hearts. And if we look at a deck of cards, there's a 4, there's another 4, there's a third 4, and of course here's the 4 of hearts. But the 4 of hearts we've counted twice as being both, there's 4 of them. We're looking at 7s. So, there's a 7 of clubs, a 7 of spades, a 7 of diamonds. But we have accounted for the 7 of hearts twice as being both a 7 and a heart. So we just subtract 1 out of 52. And for some of you, I know you probably see that coming, and maybe you only think of 3 of the 7s out of 52, and then you add the 13 hearts. But this is how we do it. So again, the 4 out of 52, those are the 7s. These are the hearts. And we remove the overlap, which in this case was the 7 of hearts. And so, 4 plus 13 is 17, minus 1 is 16. And we just reduce 16 out of 52. So 16 over 52, math, enter, enter, and we get 4/13 for this part A. We keep going. Now it says a queen or a red card. And again, there is overlap here. And it's an OR problem, so we're going to add. There are 4 queens in a deck of cards. There are 4 of each like value card. Your numbers 2 through 10, and then Jack, Queen, King, Ace. There are 4 of each of those cards. So 4 out of 52. And then red cards. We can think about it as 26 out of 52 if we're going to use the same denominator. I mean, you can do it in the calculator as 1/2. I don't know what's easier for y'all to understand. But we can look at it both ways. And then we have to subtract the overlap. There are 2 red queens. There's a queen of diamonds and a queen of hearts. And so we subtract those 2. So here I'm just using the same denominator of 52 the whole way. So 4 plus 26 is 30, minus 2 is 28. So we can do 28 out of 52, math, enter, enter, and we get 7/13. That's how I kind of think about it, but how might you think about it? Well, maybe you think about the deck being half of it is red. So there are 4 queens out of 52. Or drawing a red card would be 1/2, but we still have to subtract the 2 cards. And so your calculator will do this for you. I always put my fractions in parentheses. So let's do that now. 4 out of 52 in parentheses plus 1/2 in parentheses minus the overlap in parentheses. And we math, enter, enter, and we still get 7/13. So, whichever way you kind of think about it. And then part C, I'll go down here, a heart or a club. Now here there is no overlap. Hearts and clubs are different suits, so there would not be any overlap. So a heart or a club, that's half the deck. But there are 13 of each suit, so 13/52 plus 13/52 gives us 26/52, which is 1/2. Anytime it doesn't matter what suits they are, if it says one suit or another suit, the probability is 1/2 because that's half the deck. That was just one question, and we're at the 8.5 minute mark. That's all right. I try to keep the videos to like 20 minutes. So I'll just kind of title them by the number of questions that we go over. So now, number 2, we're still drawing cards from a deck. An ace or a queen. No overlap there. The overlap would be like a value card and a suit, like drawing a 4 or drawing a diamond. If it's 2 value cards, there's no overlap. So there are 4 aces, there are 4 queens. So 4 out of 52 plus 4 out of 52 is 8 out of 52. And I won't pull up the calculator every time. That becomes 2/13. A queen or a heart. So again, a heart is a suit. So here there will be overlap. For a queen, there are 4 out of 52. For a heart, it's 13 out of 52, or it's 1/4. I don't know if students think about it that way, but any suit is 1/4. But we can call it 13 out of 52. But we must subtract the overlap, which is just the queen of hearts, just one card. If it says like a queen or a red card, then there would be 2 overlapping cards. But a queen or a heart leaves us with just 1 overlapping card. So 4 plus 13 is 17, minus 1 is 16. Or you just put the whole thing in the calculator, and 16 out of 52 becomes 4/13. Again, it will tell you, I guess in this case, it just only gave you the option of the little fraction button. But on the test, just look at how it asks for the probability. Again, probability is between 0 and 1. I like to bring that up. In a fraction, 2 out of 13 or 4 out of 13, as long as the top is smaller than the bottom, we have a value between 0 and 1. So now we have an 8 or a 9 or a spade or a club. So in Alex, it breaks it down, the overlapping cards, and there's a lot. There's the 8 of spades, the 8 of clubs, the 9 of spades, and the 9 of clubs. So there are 4 overlapping cards. Since I have these right here, and they're in order. So a spade or a club, we're talking about the black cards, but it also asks for an 8 or a 9. So we're going to include all the 8s and 9s, meaning the 8 and 9 of hearts and diamonds. But we can't account for these twice. We cannot account for these twice. So we have to subtract 4 overlapping cards. So I'll kind of label these because we're doing a lot of them. We're going to look at 8s, 9s, spades, and clubs. For any value card, there are 4 of them out of 52, plus 4 out of 52. For any suit, there are 13 of them. But we must subtract the 4 overlapping cards. So I do it this way so that the denominators are the same and I can just add across the top. But if you want to put this all in the calculator at once, that's fine too. And maybe you thought about spades and clubs as being 1/2. And yes, we could like combine this and it becomes 1/2. So there's a lot of different ways you could kind of mentally think about this. But across the top, not the answer, 4 plus 4 plus 13 plus 13 minus 4. So how many 8s, 9s, spades, and clubs, and then remove the 4 overlapping cards do I have? That's 30. And 30 out of 52 reduces to 15 over 26. If there are any of these that you don't understand, feel free to reach out and I can go over them. in class or on a video. We'll look at a couple more in this first video. For number 3, we have a table, and here we're considering mail. For a certain day, the postal carrier distributed the following number of each type of item. So the types of items are first-class letters, ads, or magazines, and then they are delivered to either a home or a business. And there will be overlap to consider on these table questions. Also, one of the first things we need to do is find the total. So these are things you might want to put on your note card. If it's a table question, there will be overlap to consider. And your first step is to find the total. I haven't added these up, so let's see. We have 1351 plus 16 here. I added them up in one of the other problems, but not this one. So 5591 is our total. And so now that will be the denominator. The total, in case that's not clear, is your denominator. So find the probability that the item was an ad or it went to a home. So here's our ads, and then we're going to consider all the pieces of mail considered to a home, but that does mean that we'll have an overlap. So I'm going to add up my ads, and I'm going to add up the pieces of mail delivered to a home, but I'm going, as you see, we circled this one cell here of the table, 1405 twice. So we must subtract the overlap. So for ads, we have 1405 plus 252. That makes 1657. I'm going to add horizontally here for the homes. I'm just doing this on my phone. 1351 plus 1405 plus 850 gives us 3606. So maybe when you do it, you just don't add the 1405 twice, but I'm going to consider the ads, which is 1657, plus all the pieces of mail which went to a home, 3606, and I'm going to subtract my overlap of 1405. And I get 3,858. And this does not reduce. Maybe yours will, but 5,591 doesn't reduce well. So there we have it. 3,858 over 5,591. Then it asks for just the probability that the item was an ad. We've already added these two values. So that's 1657 out of 5,591. It's the number of ads divided by the total. It's just asking for one category, so there's no overlap. And then finally, the item was a first-class letter or it went to a home. And so here there will be overlap. So first-class letter, let's see, that's 1351 plus 1631. There were 2,982 first-class letters mailed out. And then we already added together these values and got 3606. That's the mail going to a home. But then we counted first-class letters going to a home twice. So we subtract that out. And so you just add these and subtract 1351, and I get 5,237. Sorry. So that's 5,237 over 5,591. So it's just the same denominator each time because this didn't really reduce, 5,591. Perhaps yours will. But we had two cases in which we had overlap. So look at your categories. For ads and first-class letters, we're able to just add vertically. For the home or the business category, we have to add horizontally. And so you'll have overlap when you do that. And I guess I'll stop there for this first video, which is questions 1 through 3.